Welcome to The Explainer. Have you ever wondered if the most mind-bending ideas in modern physics, things like black holes and the very fabric of reality, could actually be echoing some of the most ancient spiritual concepts? Well, today we're diving into a fascinating source called the Quantum Digester, and it explores that very question.
So, to get started, let's look at a symbol you've probably seen before, the Ouroboros. Yeah, the ancient image of a serpent eating its own tail. For thousands of years, this has been the symbol for a cosmos that's constantly consuming and renewing itself in a never-ending cycle. It's a really powerful mythic idea. And that leads to the big question, right? Is this just a cool ancient myth? Or, just maybe, could modern science, with all of its crazy equations and experiments, actually be pointing toward a universe that behaves in a way that's, well, remarkably similar? That's the core idea we're going to unpack today.
All right, to even begin to build this bridge, we need to start with some ground rules. Think of these as the fundamental, non-negotiable laws of physics, basically the operating system for our entire universe. So rule number one is unitarity. It's a cornerstone of quantum mechanics, and what it really means is that information can't just be created out of thin air or destroyed. Now, for a long time, black holes looked like the ultimate rule breakers, these cosmic shredders that just deleted whatever fell into them. But the thinking now is that the information isn't destroyed, it's just scrambled, and eventually it all gets back out. The takeaway? In our universe, nothing is ever truly lost.
Rule number two is Landauer's principle, and this one is absolutely fascinating. It basically says that information isn't just an abstract idea, it's a physical thing. And the act of erasing it, of forgetting, well, it isn't free. It has a real, tangible cost. It requires a bare minimum amount of energy that has to be paid, usually as heat. The source we're pulling from puts this so beautifully. At the foundation of physical law lies a moral echo. Nothing is free, not even oblivion. It's this idea that the universe has a kind of built-in accountability. Every single action, even the simple act of forgetting something, has a price tag. And look, this isn't just some philosophical concept. It is hard, physical reality. This equation might look a little intimidating, but don't worry about the symbols. What it represents is something very, very specific. The absolute minimum energy you have to spend to erase a single bit of information. It's the literal physical price of oblivion. Okay, rule three is the holographic principle. And this is where things get really, really weird. It suggests that our three-dimensional reality might just be a projection, kind of like a hologram. So all the information that makes up this room, you, me, the air, could theoretically be fully described just by the information encoded on its two-dimensional surfaces, like on the walls. Our 3D world could literally be a reflection of a 2D reality. Wild, right? And finally, while we all know the Big Bang is the standard model, there are other serious theories out there. Loop quantum cosmology, for instance, suggests our universe didn't start with a bang at all, but with a bounce from a previous collapsed universe. Other models imagine our universe being born from the collision of higher dimensional membranes, or brains. So the big takeaway here is that a cyclic, self-renewing universe isn't just for ancient myths. It's a real possibility that physicists are exploring right now. Okay, so let's shift gears. We're moving to our second pillar. We're going to see how these strange physical rules resonate with some equally profound ideas from theology. We're kind of moving from the how of the cosmos to some ancient attempts to understand the why. A really central idea here is kenosis. It's an old Greek word that means to empty oneself. Now, in theology, this doesn't mean a loss of divinity. It's the exact opposite. It's the idea that for creation to even exist, with its own freedom and its own rules, the divine has to voluntarily pull back, to self-limit, to make space for it all. It's a creative act of letting go. Another key concept to get is pantheism. Now be careful, this isn't the same as pantheism, which says the universe is God. Pantheism suggests the universe exists within God, kind of like how a thought exists within a mind. The whole cosmos is in God, but God is also way, way bigger than and transcends the sum of the entire cosmos. Okay, now for the part where it gets really fun. We're going to build that bridge between these two pillars. But it's really important to be clear about something. We are not trying to prove theology with physics. That's not the goal. Instead, we're going to use the language of physics as a powerful new metaphor, a new lens to look at these ancient ideas. So let's make our first connection. In physics, we've got entropy.
This unavoidable, irreversible cost for every single thing that happens. Every star that shines, every thought you have, it all increases the universe's entropy. It's a cosmic tax. Now think about kenosis, that theological idea of a divine cost, a self-limitation that allows the universe to even exist. The source we're looking at suggests that maybe, just maybe, entropy could be the physical echo of this divine act of giving. This slide right here really lays out the core argument. It's like the cheat sheet. On the left, you've got the hard physics, unitarity, the holographic principle, a big bounce. And on the right, you have their theological counterparts, divine memory, panentheistic containment, cosmic rebirth. You can see this amazing mapping of mechanism to metaphor, showing how these two very different worlds can actually speak to each other. And let's use the black hole as the perfect example. Physically, it's an incredible information compressor that, because of unitarity, has to eventually give back everything it takes in. But the source offers this incredible metaphor, the black hole, as an informational synapse. Think about it. A synapse in the brain helps form memories, so the black hole becomes a place where cosmic memory is preserved, a physical echo of the idea of divine remembrance, where nothing and no one is ever truly forgotten. So after all that, what's the big takeaway? Why does it even matter that we can build this kind of bridge between physics and theology? What's the point? Well, the goal isn't to use one to prove the other. It's about creating a dialogue, a conversation. Science is fantastic at giving us the how, the testable mechanisms of the universe. Theology has always been about the why, the search for meaning and value. And by using these kinds of careful, disciplined analogies, we can let these two powerful ways of understanding the world inform and enrich each other without getting them mixed up. This entire approach really depends on something called epistemic humility, which is just a fancy way of saying we should be humble about what we think we know. It's about recognizing that both science and theology have limits, right? Science can't tell you the meaning of life, and theology can't predict next week's weather. It's this humility, this respect for boundaries, that opens the door for a real conversation to happen. And this brings us to this really powerful final image from the source. Instead of picturing a cold mechanical universe that's just slowly running out of steam and dying, we're left with this vision of a dynamic, living cosmos, a system built on remembrance and renewal, a universe that is, in a deeply metaphorical sense, praying. So let's end on this thought. If the universe isn't just a machine, but a living story that's still being told, what does that mean for us? If science and myth can come together to create a richer, deeper understanding of everything, what new chapters will we, as a part of that story, choose to write?
Welcome to the deep dive. This is where we really get into the weeds on some complex ideas, theories, insights from, well, all over the place, really. And we tried to distill them, make sense of them, so you get the big picture without, reading dozens of dense papers.
And today, this one's ambitious. Probably our most ambitious yet, wouldn't you say?
I think so. We're not just connecting, say, physics and biology. We're diving into this framework called the Quantum Digester.
Quite a name.
It really is, isn't it? Instantly makes you think of something cosmic happening, some kind of consumption and reprocessing on a grand scale.
And that's pretty much the core idea in the source material we're looking at.
Right. So our mission today is to unpack this thing, this conceptual model that tries to weave together information theory, black hole thermodynamics, and even metaphysics. Specifically, this concept called kenosis.
Kenosis, yeah. The idea of divine self-limitation. It's a heavy mix.
Definitely. And the stakes, well, they feel pretty high. Physics, especially in the last few decades, has really shifted. People talk about this informational turn.
Absolutely. Things like black holes, even the whole universe's boundary.
Right.
We're now trying to understand them fundamentally in terms of information content, not just mass or energy. Information sort of taking center stage.
Yeah, it feels central now. And the analysis we're diving into today, it pushes that. It treats the universe less like a machine just winding down.
Like the old heat-death idea.
Exactly. And more like a self-processing system. That's the phrase they use. It's this blend of hard physics and something almost mythic.
So our goal has to be really precise here. Surgical, as you said earlier. We need to unpack the methodology they use, which is quite layered.
Yeah, the authors are very clear about this. They structure it to avoid, intellectual shortcuts or maybe wishful thinking.
Right. They separate the science, the sort of non-negotiable physics, into what they call layer 0 and layer 1, L0 and L1.
Bedrock stuff.
Bedrock. And only then, on top of that foundation, do they build the analogical framework, the theology, the metaphysics, that's layers L2 through L4.
And sticking to that structure is crucial. We really need to avoid what they call the category error.
The cardinal sin, yeah. Mistaking a physical mechanism for a metaphor, or maybe reading a metaphor as literal physics. It happens all the time in these kinds of discussions.
It does. So we gain insight by keeping those layers distinct. Let's start where they start. The physics, the non-negotiable stuff. Okay, part one, the physics. And we have to begin with probably the most famous cosmic puzzle of the late 20th century, the black hole information paradox.
Right. It all kicked off when Stephen Hawking did his calculations on black hole radiation, Hawking radiation.
And the initial takeaway was, well, it was deeply troubling for physics, wasn't it?
It really was, because it seemed to imply that information was being destroyed permanently if you threw something, say, your favorite physics textbook, into a black hole.
Not that I would.
Of course not. But hypothetically, if you did, as the black hole evaporated over eons, the radiation coming out wouldn't contain the information needed to reconstruct that textbook. The specific quantum details, the history of the particles that made it up, seemed lost forever.
And that just flies in the face of quantum mechanics. It violates unitarity.
Exactly. Unitarity is, it's practically sacred. It's the bedrock principle that says information in the universe is conserved. It can be scrambled, hidden, transformed, but never truly erased.
It's like the universe keeps perfect books. If unitarity fails, our whole understanding of cause and effect, of how the present state determines the future, just breaks down.
It dissolves, yeah. Fortunately, decades of intense work, especially more recently with things like the page curve analysis and these ideas about quantum islands near the horizon.
Islands? That sounds intriguing.
It is. It's complex quantum gravity stuff. But the upshot, the consensus view now, is that the evaporation process is unitary after all. Information isn't destroyed.
Okay, so the old picture black hole as this ultimate vault, this information sink that's out.
It's out. The new picture, and the source material uses this phrase, which I quite like, is the black hole as an extreme compressor.
Like a cosmic zip file.
Precisely. It takes the information, scrambles it incredibly effectively, and encodes it. Not deleted, encoded. It gets woven into these very subtle correlations, quantum entanglements, between the radiation emitted early in the evaporation and the radiation emitted much later.
So the universe's books do balance. The history isn't lost. It's just incredibly hard to read.
Exactly. Recovering it would be practically impossible, but theoretically the information is still there. Unitarity holds.
Okay, so information is conserved. That's pillar number one. And it connects directly to the second big physics idea here, holography, which comes out of the Beaconstein-Hawking entropy discovery.
Yes, this was another game changer. Usually for any normal system, think of a cloud of gas, its entropy, which is a measure of its disorder, or equivalently its information content.
Right, more disorder, more ways things could be arranged, so more information needed to specify the exact state.
Exactly. And that usually scales with the volume of the system. Double the volume, roughly double the information capacity.
Makes intuitive sense.
But Jacob Beaconstein and then Stephen Hawking showed that for a black hole, the entropy, the information capacity, scales not with its volume, but with the area of its event horizon. The surface area. The formula is proportional to added dollar.
Area, not volume.
That's deeply counterintuitive. Why would the information limit depend on the boundary, not the space inside?
That's the profound mystery that leads directly to the holographic principle. It suggests, radically, that the maximum amount of information you can pack into any 3D region of space is actually limited by the information capacity of its 2D boundary surface.
Like the information lives on the surface, somehow encoding everything within.
Sort of, yeah. It's a huge conceptual leap and suggests that maybe space-time itself, the geometry, is fundamentally linked to information storage, that space behaves a bit like a memory register.
So the universe might be like a hologram, where the 3D reality we experience is somehow encoded on a distant boundary surface. That's the strong version, yes. Even the weaker versions imply this deep connection. Geometry and information are two sides of the same coin. The area of a horizon, like a black hole's event horizon, or maybe even the cosmic horizon, acts as the ultimate record keeper for everything that happens inside. The boundary holds the key.
All right, so we have information conservation via unitarity and information limits via holography linked to area. Now, let's bring it down to the level of computation itself with Landauer's principle.
Yes, Landauer's principle is crucial because it makes it absolutely clear. Information isn't just some abstract mathematical idea, it's physical. It has real-world consequences.
What does it state exactly?
Rolf Landauer showed quite rigorously that there's a fundamental minimum energy cost associated with processing information. specifically the act of irreversibly erasing one bit of information.
Like resetting a switch from on back to a default off state, forgetting its previous state.
Exactly that. That act must, thermodynamically, dissipate a minimum amount of energy as heat into the surrounding environment. The minimum cost is p kilo dA TLN22.
Let's break that down. Kildollars is Boltzmann's constant, just a conversion factor. Teldollars is the temperature of the environment it's dissipating into. And Tolly2 comes from the fact that a bit has two states.
Right. So the hotter the environment, the higher the energy cost to reliably erase that bit. The key point is, forgetting isn't free. It costs energy.
This feels really fundamental. It's like the universe charges a tiny energy tax every time a computation involves losing information.
That's a great way to put it. It has a minimum hardware cost, even for the simplest possible irreversible operation, forgetting one bit. Now, for a single bit, that energy is minuscule, obviously. But think about all the information processing happening constantly throughout the universe.
Biological systems, stars forming, even just particles interacting.
All of it. The aggregate cost becomes enormous. And this principle is what finally solved the old paradox of Maxwell's demon.
Ah, yes, the clever little demons sorting hot and cold molecules, seemingly violating the second law of thermodynamics by reducing entropy without doing work.
Right. The demon appears to create order for free, but Landauer's principle points to the demon's memory. To sort the molecules, the demon has to store information. This one's hot, put it left. This one's cold, put it right.
Okay.
Eventually, the demon's memory gets full. It has to erase that information to keep sorting. And that act of erasure, resetting its memory bits, dissipates heat. That's where the entropy increase required by the second law actually happens. The cost is paid in the demon's information processing.
So the book's balance again. Forgetting somewhere means heating up somewhere else. Information flow and thermodynamic cost are locked together.
Two sides of the same coin. It enforces the second law right down at the level of basic computation.
And this ties back to black holes too, right? With the generalized second law.
Perfectly. When something falls into a black hole, you might think the entropy outside decreases, which seems bad for the second law.
Right.
But the black hole's own entropy, its Beakenstein-Hawking entropy linked to its horizon area, increases.
And the generalized second law states that the total entropy, the entropy outside plus the black hole's entropy never decreases.
Exactly. The black hole's horizon area grows by just enough or more to compensate for the entropy that fell in, ensuring the overall thermodynamic budget is respected. Gravity itself seems to obey these informational and thermodynamic rules.
Okay, so we've got a universe that conserves information, unitarity, limits it based on boundaries, holography, and charges an energy cost for processing it, Landauer. Now, how does this setup relate to the idea of cosmic cycles? Can the universe actually repeat itself, renew itself?
This is where we hit a major classical obstacle. The idea of a cyclical universe, sometimes called the Ouroboros model after the snake eating its tail.
Ancient idea, very powerful mythically.
Very. But physics, specifically classical thermodynamics, threw up a big roadblock known as Tolman's problem. Richard Tolman pointed out that if the universe went through cycles of expansion and contraction, the second law would still apply.
Meaning the total entropy, the total disorder, would increase with each cycle.
Precisely. Every cycle would generate more entropy than the last. So if a universe collapsed in a big crunch and then somehow re-expanded in a new Big Bang, it would start the next cycle with higher entropy.
Which means that subsequent cycles would have to be, what, longer, bigger, cooler?
Yes, progressively longer, larger, and more dilute or cooler. You'd get these ever-expanding, weakening cycles. It prevents a true, identical recurrence. You can't get back to the pristine, low-entropy state needed for a vibrant new beginning if you're carrying all the accumulated disorder from the previous round.
So the classical picture seemed to forbid a truly cyclic universe. The entropic buildup acts like a barrier.
It does. But this is where modern physics, the L1 layer theories, plausible but still theoretical, offer potential ways around Tolman's barrier. This is absolutely critical for the quantum digester idea. It relies on these L1 models being at least conceptually viable.
Right. They don't have to be proven fact yet, but they need to be physically coherent possibilities. What are some of these models?
One major contender comes from loop quantum cosmology, or LQC. It's derived from loop quantum gravity, which tries to quantize space-time itself, replacing Einstein's smooth fabric with a kind of granular quantum geometry, discrete loops and nodes.
Okay, so space itself has a minimum scale, a quantum structure.
That's the idea. And near the scales where classical physics predicts a Big Bang singularity, infinite density, infinite curvature LQC, predicts something completely different happens due to this quantum geometry.
What happens?
As the universe contracts down to incredibly high Planckian densities, the quantum nature of geometry itself effectively creates a powerful repulsive force. It's like space-time fundamentally resists being compressed beyond a certain point.
So instead of collapsing infinitely into a singularity,
It bounces. The contraction halts, reverses, and transitions into expansion. The Big Bang singularity is replaced by a big bounce. It's a physical mechanism arising from quantum gravity that avoids the infinite crunch and potentially allows the universe to pass through this bottleneck from one eon to the next.
a bounce. That could potentially reset conditions or bypass the worst of the entropy problem.
It's one possibility for overcoming the barrier. Another set of ideas comes from string theory, often involving extra dimensions or branes. These are the ekpyrotic and cyclic brane models.
Ekpyrotic, meaning conflagration or coming out of fire.
Yes. These models propose cycles driven by collisions between these higher dimensional branes. Instead of a bounce per se, they often involve a period of very slow contraction before the bang.
How does slow contraction help with entropy?
The idea is that during this ultra-slow crunch phase, the universe gets incredibly smooth and flat. Irregularities and anisotropies, the things contributing to entropy, get diluted or damped out very efficiently. Then, the brane collision triggers the hot expanding phase, effectively starting the new cycle in a very low-entropy, smooth state. It's less about reversing entropy and more about purifying the universe during the contraction.
So different mechanisms, a quantum bounce, slow contraction, and purification, but both aiming to solve Tolman's problem, to get past that entropic barrier.
Exactly. They are sophisticated theoretical attempts to reconcile cyclicity with fundamental physics.
We should inject a note of caution here, though, following the source material's own rigor.
Absolutely.
Yeah.
LQC and ectorocyclic models are physically plausible L1 theories, but they are definitely not the standard cosmological model, which is currently inflation. Their observational evidence is still lacking or ambiguous.
And the source also mentions Penrose's conformal cyclic cosmology, CCC, as another example.
Yes, CCC is conceptually beautiful. The idea that the infinitely expanded cold future of one eon mathematically becomes the Big Bang of the next through a conformal rescaling, but it's also highly contested, observationally and theoretically. It serves as a good reminder that these cyclic ideas, while maybe possible, are still on the frontiers of physics.
Okay. But the crucial point for the quantum digester framework is that L1 physics does provide these conceptually coherent pathways. Tolman's problem isn't necessarily insurmountable anymore.
That's the key takeaway from the physics part. Let's recap the 4 pillars we've established from L0 and L1. 1. Unitarity holds. Information is conserved, even through black holes. 2. Holography limits information by area, suggesting space is like a bounded register.
3. Landauer's principle shows there's an energy cost to erasing information, linking computation to thermodynamics.
And 4. Modern quantum cosmology models like LQC or cyclic models offer plausible, if unproven, ways to overcome the classical entropic barrier to cosmic cycles.
So the physics foundation allows for a universe that remembers everything, has finite capacity, pays for its actions, and might be able to repeat itself. That sets the stage for the interpretation.
Precisely. Now we can move to layers 2 and 3 where the analogy and meaning making begin, right? So now we make that crucial shift. We're moving from the physical mechanism, L0, L1, to the interpretive framework, L2, L3. And the central concept they introduce here is kenosis.
Kenosis, you mentioned it earlier, from Greek, meaning to empty oneself. What's the theological context?
Classically, in Christian theology, it comes from a passage in the New Testament, Philippians chapter 2, describing Christ emptying himself, taking the form of a servant. More broadly, it's interpreted as this idea of voluntary divine self-limitation. God choosing to yield divine power or infinitude, to constrain God's self in order to create and relate to something finite, something other.
Choosing finitude for the sake of creation. Okay. How does the quantum digester model connect this to physics?
The core analogical move, the heart of layer 2, is to map the second law of thermodynamics onto this logic of kenosis.
How does that work? The second law says entropy increases, disorder grows. How is that self-emptying?
Think about it through Landauer's principle, which is underpinned by the second law. What did Landauer tell us?
That creating structure, processing information, erasing bits, any act of differentiation or computation has an unavoidable thermodynamic cost. It generates entropy, dissipates heat.
Exactly. You cannot create novelty. You cannot become determinate. You cannot run the processes that make existence interesting and evolving without paying that entropic price.
Yeah.
The universe literally has to spend its available order, its low entropy, to make things happen.
Ah, I see. So the continuous increase of entropy isn't just decay. It's the necessary cost of creation, the cost of becoming, the cost of relationship and interaction.
Precisely. It's the physical expenditure required for the universe to differentiate and evolve. And this physical spending of order mirrors the theological concept of kenosis, the divine willingly yielding stability, pouring itself out, limiting itself to allow creation to unfold. The source calls this the kenotic metabolism of the cosmos.
Wow. Okay, that reframes entropy significantly. If you adopt, as the source suggests, a panentheistic viewpoint for a moment.
Panentheism meaning all in God, the idea that the universe is within God, but God also transcends the universe.
Right. If you take that view, then entropy isn't just the universe running down. It's a sign of divine participation. The cost God pays to be in time, in process.
That's exactly the interpretation offered. Entropy becomes almost like a physical sacrament, marking the ongoing divine choice to inhabit finitude, to be bound by the very physical laws that make relationship and novelty possible. The cost is the participation.
And within this framework, the black hole takes on a special significance, doesn't it, as the ultimate kenotic structure?
It does. Think about its behavior. It passively accepts and absorbs everything that falls in matter, energy, information, total submission, maximum compression. It empties the surrounding region into itself.
But then it doesn't just hoard it forever,
Right.
based on the L1 physics.
Exactly. Through Hawking radiation,
Mhm.
over immense timescales, it slowly radiates its absorbed essence, its informationally rich content, back out into the universe. This cycle of complete absorption followed by slow, complete release is read as a profound symbol of kenotic action, perhaps even divine reciprocity. The ultimate servant structure, taking everything in only to eventually give it all back.
Let's dwell on that panentheistic context a bit more, because the source seems to rely on it for the next step, connecting to holography. Can you define panentheism clearly again?
Sure. It's crucial to distinguish it from pantheism. Pantheism says all is God. The universe and God are identical. Panentheism says all is in God. The universe exists within the divine reality, like thoughts within a mind, perhaps. So God pervades the universe, is intimately present in it.
But God also transcends it. God is more than just the sum total of the universe.
Exactly. It preserves both divine immanence, presence within, and transcendence, otherness, beyondness. And the authors argue this specific theological structure finds a remarkable parallel in the physics of the holographic principle.
How so? Holography says the information of a 3D volume is bounded by its 2D surface area.
Right. So think of the 3D bulk, the universe we experience, with all its energy, matter, information as being contained, encoded, sustained by its boundary, the holographic screen.
Okay, so the created world is like the bulk held within this boundary.
And that boundary represents the immanent aspect of the divine, the encompassing reality that holds and structures creation. The Bekenstein band, the physical limit on information density, AP Bell-de-Sukkar, becomes a kind of metaphor for the necessary finitude of creation, the limits God accepts for a coherent world to exist.
But panentheism requires transcendence, too. God has to be more than just the boundary holding the universe. How does the analogy account for the God beyond the system?
This is where they bring in a fascinating, though admittedly more speculative concept from theoretical physics. The idea of zero bits.
0 bits, what on earth are those?
They emerge in some advanced theoretical explorations of holography and quantum information, particularly when looking at information that might not be fully captured by the standard boundary description. Conceptually, you can think of them as representing a kind of latent informational potential of the system. Information resources that are intrinsic to the reality, but maybe not directly measurable or accessible from within the bulk, or even fully accounted for on the simple boundary.
Like hidden potential, information that's off-screen but still part of the ultimate reality.
That's a good way to think about it. It's theoretical, mind you, L1 bordering on L2, perhaps.
Yeah.
But analogically, the source maps these 0 bits onto the transcendent dimension of the Godhead. They represent the infinite remainder, the unbounded potential that exceeds the finite holographic description of the created universe.
So the 0 bits are the symbolic reservoir that allows for genuine novelty, for regeneration, ensuring the system isn't truly closed or finite in an ultimate sense.
That's the interpretation. God is both a holographic boundary actively sustaining the world, immanence, represented by the Beaconstein bound on the area, and the transcendent source of potential beyond that boundary, transcendence, represented by the 0 bits. It's an attempt to find physical concepts that resonate with both aspects of panentheism.
Fascinating. Let's bring the black hole back into focus, but with a new interpretive lens suggested by the source of the black hole as an informational synapse.
Yes. Think about what a synapse does in the brain. It's a junction, a critical point where signals from many inputs converge, get processed, integrated, transformed, and then potentially trigger new outputs. It's a node of intense information processing.
Okay, a point of connection and transformation.
The analogy suggests the black hole functions similarly on a cosmic scale. It's a region where matter, energy, and crucially the information they carry from potentially vast regions of space are drawn in, maximally compressed, and integrated. The complex quantum state of the horizon becomes this incredibly dense record of everything that fell in.
And then, through Hawking radiation, this integrated information is transformed and emitted back out eventually as correlations in the radiation.
Exactly. It acts as a cosmic hub for information integration and transformation.
Now, the source material is extremely careful here. They insist this is a structural analogy only. Why the strong warning against confusing this with consciousness, like in integrated information theory, IIT?
It's absolutely vital for their methodology. IIT, for instance, tries to link specific types of complex information processing directly to the presence of subjective experience, of consciousness. Claiming a black hole is conscious, based on this analogy, would be a massive category error.
Jumping from processes information intensely to is aware.
Precisely. It would be imposing a high-level metaphysical property, consciousness, L4 perhaps, onto a physical system, L0, L1, based purely on a functional resemblance, L2. We can observe and model the black hole's informational dynamics, its capacity to integrate and transform inputs without having any grounds whatsoever to claim it has qualia or subjective awareness.
So the analogy highlights the function information integration without making unwarranted claims about sentience. It's about structural similarity, not identity of being.
Exactly. Preserving that distinction is key to the whole framework's integrity. Once we respect that boundary, though, the idea of the black hole as an integrator links beautifully with another theological concept, divine memory, especially when paired with quantum unitarity.
Unitarity, again, information is conserved. How does that become divine memory?
Well, if the fundamental laws of physics insist that no information about the state of the universe is ever truly lost, even when it falls into a black hole,
then in a sense, the universe remembers everything. Every event leaves an indelible informational trace.
Correct. The black hole doesn't destroy the history of what falls in. It encrypts it, stores it in the entanglement patterns of its quantum state, primarily on the horizon, and the subsequent evaporation process is like an act of anamnesis.
Anamnesis, remembrance, recalling things previously forgotten.
Yes. The black hole slowly releases this encrypted history back into the cosmos through the subtle correlations in its radiation. The universe recalls its own past.
So from this perspective, theological ideas like redemption get an interesting physical echo. Redemption as the regathering, the recoherence of information that was scattered or seemed lost.
That's the symbolic connection being drawn. The deep hope that ultimately nothing precious is lost finds a resonance in the physical principle that information, the very identity of things, persists.
And the Hawking radiation itself, photons emerging from the black hole's darkness.
Because a potent parable, light returning from the abyss, order and information being reborn from apparent chaos and collapse. It's interpreted as a symbol of resurrection, physically grounded in unitary evaporation.
To wrap all this physics and metaphysics into a more narrative shape, the analysis moves to layer 3, mapping these processes onto some powerful, ancient, mythic archetypes.
Right, giving the abstract concepts a more visceral, story-like feel. The first archetype they use is Sophia, often representing divine wisdom in various traditions.
How is Sophia mapped onto the physics?
Sophia is identified with the integrated information that emerges from the cosmic process. Think of the information encoded and then released by black holes, or perhaps the structured information that organizes the universe after a cosmic bounce or renewal. It's the accumulated knowledge or wisdom gained from a previous cycle, forming the blueprint for the next. The intelligence inherent in the cosmic memory.
Okay, Sophia, as the informational content, the wisdom. What's next?
Next is Shakti. In Hindu traditions, Shakti represents the primordial cosmic energy, the dynamic power of creation and transformation, pure divine force.
And the physical correlate.
This maps quite directly onto the physical engine of cosmic renewal itself. In LQC, it's the quantum bounce, that powerful repulsive force arising from quantum geometry that drives the universe from contraction back into expansion. In cyclic brain models, it might be the energy released in the brain collision. Shakti is the raw power that overcomes collapse and fuels rebirth.
So Sophia is the information, Shakti is the power, and they are brought together by
By the overarching symbol of the Ouroboros, the serpent eating its own tail. It's arguably the most universal symbol of cyclicity, self-consumption, and eternal renewal.
the perfect emblem for the quantum digester idea.
Exactly. In this mapping, the serpent's head doing the consuming is the black hole, the informational synapse, processing the old eon. The tail, looping back around for rebirth, represents the quantum bounce or the cyclic transition mechanism, Shakti's power, initiating the new eon.
And entropy, where does that fit in the Ouroboros myth?
Entropy, the seemingly waste heat generated by the cost of existence, Landau Kenosis, is re-envisioned. It's not just waste, it's the necessary gestational heat of the whole process. It's the thermodynamic signature of the serpent digesting its own tail, the unavoidable byproduct of the transformation that makes renewal possible. It binds the physics of conservation, cost, and recurrence into one potent cyclical narrative. Okay, we've journeyed through the physics, L0, L1, and the interpretive layers, L2, L3, with kenosis, holography, synapses, and myths. But for this whole structure to hold together intellectually, we need layer 4, the methodological synthesis. How do we relate these different layers responsibly?
Right. This is where the source material really emphasizes the need for discipline, rigor, avoiding that category error by being explicit about how the analogies work.
And the core tool they propose for this is what they call the dual column epistemology. Think of it as a table or a mental checklist.
A way to keep the lanes separate but see the connections.
Exactly. On one side, you list the physical mechanism, the L0 or L1 science, how it works, which is ideally testable or at least mathematically coherent within physics. On the other side, you list the corresponding mythic theological analogy, the L2 or L3 interpretation, what it might mean, its symbolic resonance.
But there's a crucial third element, right?
Yes, the epistemic note. This is vital. It explicitly defines the nature of the link between the columns. Is it a structural analogy, a functional parallel, a symbolic resonance, an ethical illustration? This note prevents you from mistaking the analogy for an identity or a causal link.
Let's revisit some examples using this structure just to make it concrete.
Okay. Physical mechanism, Bacon-Stein-Hawking entropy, information scales with area, mythic theological analogy, kenotic metabolism, divine self-limitation to create. Epistemic note, structural analogy. The universe's information structure resembles a system undergoing self-limitation.
Another one, physical mechanism. Landauer's principle, erasure costs energy. Analogy, the cost of knowing becoming, sacrifice needed for differentiation. Epistemic note, illustrative of ethical dimension. Suggests physical laws have a structure that echoes ethical concepts like cost-consequence.
One more. Mechanism, page curve unitarity. Information conserved in black hole evaporation. Analogy, divine memory and amnesis, all experience conserved, recalled. Epistemic note, symbol of eschatological redemption. The physics serves as a powerful symbol for ultimate hope and coherence.
So the dual column approach forces clarity. The analogy isn't presented as proof, but as a resonance, a shared logic maybe.
Precisely. Analogy functions as a cognitive bridge, helping us trace patterns of coherence across different domains of knowledge without illegitimately collapsing them. When the source says entropy is kenotic, it's not claiming God as the second law. It's observing that the physical necessity of irreversible costs in creation, entropy, shares a deep structural logic with the theological concept of generative sacrifice, kenosis. They call it an irreversible generosity inherent in the physics.
This level of methodological care requires more than just being smart. The source argues it requires real, intellectual, almost ethical commitments. They stress epistemic humility.
Yes, because the history of science and religion dialogue is littered with failed concordist schemes, forced attempts to make scripture predict science or twist science to fit dogma. Usually ends badly for both.
So, what are the specific ethical principles they advocate for to avoid those pitfalls when doing this kind of synthesis?
They lay out a few key ones. First, distinction of domains. This is fundamental. Scientific claims aim for empirical testability, falsifiability. Theological claims deal with meaning, value, ultimate context. They operate symbolically. You have to respect that difference. Don't try to prove theology with physics or dictate physics from theology.
Second principle.
Transparency of metaphor. Always be explicit when you're using an analogy or metaphor. The dual column approach helps here. Label the connection clearly. Don't let the metaphor sneakily become the mechanism in the listener's mind, or even your own.
That takes constant vigilance. What's the third?
Reciprocal correction. This one's tough but important. It means theology, or the interpretive framework, must remain open to correction by scientific discovery. If, hypothetically, physics definitively prove that information is destroyed in black holes, overturning L1 unitarity, then the theological interpretation built on divine memory and redemption as recoherence would lose its physical anchor. It would need serious revision or abandonment.
Exactly. Theology can't be immune to established facts about the world it seeks to interpret. And the flip side is that physics should remain aware of its own limits, open to the larger metaphysical questions about meaning and purpose that science itself might provoke but cannot answer. Science explains the how, but often the why we care comes from a broader context.
Is there a final principle? Yes, communal verification. This kind of ambitious synthesis shouldn't be a solo project. It needs critical input from both scientific experts to check the physics and theological philosophical experts to check the interpretations and analogies. It's about checks and balances against individual bias or overreach. Basically, the whole process demands intellectual humility and restraint.
Okay, so respecting these boundaries, using the dual column method, where does the synthesis ultimately lead? What's the final picture painted by the quantum digester model?
It culminates in some pretty profound theological and philosophical claims. Perhaps the most striking is the reframing of the arrow of time, usually seen thermodynamically as the arrow of increasing entropy, of decay.
Right, the universe running down.
Here it's reinterpreted as the trajectory of love, or maybe relational becoming. Because entropy, understood kenotically, is the cost paid for relationship, for novelty, for the universe to become more complex and differentiated.
So the necessary spending of order via the second law is actually what enables connection and creation to happen. It's a cost willingly paid.
That's the idea. It's framed as a thermodynamics of grace. The fundamental laws driving cosmic evolution have this built-in character of costly generative giving. It suggests the universe isn't ethically neutral. Its basic operating system echoes principles of sacrifice and generosity.
Wow. And this connects back to information conservation, too.
Absolutely. Because unitarity guarantees that information, the unique identity and history of everything, is never ultimately destroyed. This provides a physical resonance for the deep-seated human and theological hope that nothing precious is truly lost.
So salvation, in this interpretive framework, isn't just a spiritual concept. It's linked to the idea of informational coherence restored. The universe eventually recalling and reintegrating all the seemingly lost or scattered pieces of its history.
Yes, the ultimate hope is for a final recoherence, guaranteed in principle by the conservation laws.
This leads to a final portrait of the divine that's quite different from, say, a detached clockmaker god.
Very different. The source suggests thinking of God not as a static architect, but perhaps as a living algorithm. The underlying generative process, the informational substrate of reality itself.
A process that operates through self-limitation, kenosis, to create coherence, that learns or experiences through cosmic expression, information gathering, and that renews itself eternally through these costly cycles of becoming, recursion.
It's a dynamic, process-oriented view.
Yeah.
Matter is the structure, energy drives the process, entropy is the cost, information is the memory, and perhaps love or grace describes the fundamental kenotic dynamic that keeps the whole Ouroboric cycle turning. Every event contributes to the cosmic memory bank. #tag outro.
Well, we set out on a pretty ambitious deep dive today, aiming to unpack the quantum digester model and its attempt to weave together information theory, black hole physics, and this idea of kenotic theology.
It's definitely a complex tapestry, but hopefully we've illuminated the key threads and, crucially, the rigorous methodology the source uses to keep those threads distinct yet resonant.
Yeah, the core ideas seem to be information is fundamental and conserved, unitarity. Processing it has a cost linked to entropy, which can be read analogically as divine self-giving, kenosis.
Cosmic cyclicity, while classically forbidden, seems conceptually possible within modern quantum cosmology, L1 bounce cycles. And the holographic principle offers a metaphor for how creation might be contained within, yet transcended by, its source, panentheism.
And the key is using disciplined analogy, like the dual column method, to trace these resonances without confusing science with metaphor.
Exactly.
So the big takeaway for you, our listener, maybe isn't about definitive answers, but a different way of seeing. The possibility that the universe isn't just winding down towards a cold, empty void.
Right. Instead, it might be viewed as engaged in this constant, costly process of self-renewal, a system that processes its own existence, converting structure to energy, energy to information, and that information back into new structure, cycle after cycle.
A covenant of recursion, as the source puts it, where the price of entropy is paid for every moment of connection, every bit of novelty.
It implies creation isn't a one-off event, but an ongoing process of becoming, constantly renewed through self-emptying and remembering.
So we'll leave you with that final, quite poetic image from the source material to ponder. If this picture holds any truth, then maybe what physics simply calls entropy
Could be interpreted perhaps as the incense of surrender, the fragrant cost of being.
and the entire cosmic dance from gravitational collapse into black holes to the slow radiation outward to potential cosmic rebirth, maybe that whole process could be seen as a vast, ongoing act of prayer. Something to think about.